Welcome back to the wonderful world of astronomy. This is the beginning of chapter 3 on the science of astronomy. In this chapter, we're going to look at what exactly science is, and we're going to look at the history of science, history of astronomy in particular, in ancient astronomy, and then we'll wrap up chapter 3 looking at the philosophy of science. We start with this first video, part 1, what is science? And I want you to think about that scientific thinking is not something that's reserved for people in white lab coats who are scientists for a living, chemists, physicists, astronomers, etc. But scientific thinking is really something we do in everyday life. Scientific thinking is based on everyday ideas of observation and trial and error experiments. So, for example, it could be a matter of baking chocolate chip cookies. You maybe have a recipe for chocolate chip cookies and you bake it and you've done it before. It's a favorite recipe. But this time the cookies come out burnt. Something has gone wrong. And hopefully you don't just chalk that up to bad luck, but you start inquiring and thinking, what went wrong with these cookies? And this is scientific thinking. So we could think of some ideas that are likely explanations for why the cookies burnt. And we could think maybe I left them in too long, maybe the oven temperature was on high. We can think of some outrageous ideas, such as maybe some Martians beamed into my oven, messed with the recipe, and then beamed out. But that's not very likely to have occurred. So we tend to think based on our best knowledge of the situation. We have a hypothesis, and we think such things as maybe we left it in the oven too long, maybe the oven temperature was too high, maybe I messed up somewhere on the ingredients. And so trial and error experiments, we might go back and do the cookies again, but this time maybe use an oven thermometer. Be extra careful that we set it to the right temperature. Use an oven thermometer. Be extra cautious on using the timer, be extra cautious on the ingredients, and we try to figure out using trial and error what exactly is wrong, what went wrong with that one time we baked cookies. So we think about a scientific method, and oftentimes science teachers will talk about the scientific method, and there really isn't one scientific method, but rather there are scientific methods. There's a main flow of how we do science. And I remember when I was in grade school, it was along about the 7th grade where we learned the scientific method, and we had to do some experiment that lasted over the semester and then do a project that involved putting a backboard together for the science fair. And it went something like this. You can see on this slide ahead of you or in front of you. The first is that we make observations. So based on our observations of the world around us, we might see things as the cookies came out of the oven burnt, or thinking about more things that we often put in the category of science. We might think these flowers on this side of the house grew better than these flowers on the other side of the house. There's an observation in botany. So we ask a question. Why were my cookies burnt? Why do the flowers on this side of the house grow better than the flowers on the other side of the house? We suggest a hypothesis. A hypothesis, and I'll have this defined on the next slide, but it's a best guess. It's an educated guess. What maybe is a possible answer based on our knowledge for the question that we have. So with the flowers growing better on one side of the house than the other, we could hypothesize that the one side of the house gets more sunlight. We could hypothesize that the sprinkler system works better, that the flowers on the one side of the house get more water. So we come up with a hypothesis. Then we make a prediction. So let's go with the hypothesis. Let's go with this example that I've observed that the flowers on one side of the house on the south side grow better than the flowers on the north side of the house. Why do they do that? That's the question. My hypothesis is they get better sunlight on the south side. And so make a prediction. If I maybe put them in shade on the south side, then according to that hypothesis, they won't grow as well if I put them under some shade. So then I perform a test or experiment or additional observation, and so I can actually do that test. So I put them in shade and I see if they are still growing well, then maybe my hypothesis was incorrect. So I might reject that hypothesis. In that case, as it says on the left here, the test does not support the hypothesis. So I would revise the hypothesis or make a new one. Or maybe when I put them in the shade, they grow just as well as the ones on the north side, and then my hypothesis is supported. So this goes to, on the right side, test supports hypothesis, make additional predictions and test them. All right, so you notice this loop around. We never just be satisfied with one test confirming our hypothesis and we say, aha, we've got the truth now. We want to, in science, keep on testing our hypotheses, keep on refining them. So now maybe I can see maybe the fact that they get more or less water on the south side of the house, maybe that affects their growth. And so I can go back and make a prediction and maybe do some tests that involves changing around the water, how much water they get on the various sides of the house. And then it loops around. It continues to loop around as we keep on refining our hypothesis. We keep on doing experimentation. So here's a good definition of a hypothesis. A simple explanation is it's an educated guess, but a more concise or a more accurate definition, it's a tentative model proposed to explain some set of observations, but which has not yet been rigorously tested and confirmed. So back to the first line that I wrote, it's an educated guess, but it hasn't yet been tested. And then we have a theory. When a hypothesis has been rigorously tested and the tests support that hypothesis, it then graduates to become a theory. It's promoted. So it has some observational basis to it. So a theory is a model of some aspect of nature that has been rigorously tested and has passed all tests to date. So again, a model of some aspect of nature that has been rigorously tested and has passed all tests to date. So we had a hypothesis and it's shown itself to be pretty well supported by the tests that we've done. Now, some things to keep in mind, these 3 bullet points at the bottom. Being verified by experiment or observation does not necessarily mean that the theory is true, because we can continue and we should continue to do more experiments, to make other observations, to try to poke holes in the theory. And that's what good science is, having our theories, even well-established theories, and trying to poke holes in them to figure out, are they really showing us the truth about nature? A well-verified theory may only show partial truth. So the truth that it reveals is only as good as the tests that we've put it under. Upon further investigation, it may turn out to be completely false. So when we have a theory, do not go to one extreme and say, well, it's not true, it's just a theory, because theories do have, by the definition of a theory, they have been tested, they have shown themselves, they have passed some tests. However, don't go to the other extreme and assume that just because a theory has passed tests up till now, that it is showing the truth. One theory in astronomy that lasted for several millennia but has now been discarded is the idea of the geocentric universe. And we'll talk more about this later on in chapter 3. but it had been believed for a long time that the Earth was the center of the universe, and the planets and the moon and the sun go around it, and the stars are way off in the distance surrounding the Earth. And it was based on good observation because we see everything rise in the east and set in the west. From our perspective on Earth, we don't feel motion of the Earth. It feels like it's sitting still. And it looks like everything is moving around the Earth as it goes up in the east and down in the west. And so that was based on good observation that the Earth was the center. However, it was found during the Renaissance. Various people came along, notably Nicholas Copernicus, Johann Kepler, and Galileo Galilei, and they showed that this theory needs to be discarded, that the Earth is not at the center of the universe. And again, we'll talk about that theory later on in Chapter 3. This has been your introduction to Chapter 3, and come back next time and we'll talk about ancient astronomy.